Let us start by revising the concept of lines. So here, if you have lines, if you have a straight line and a line, so you see that we have the line of which is the straight line, and the line start from A, it's A, B, C, and is joined by this line D. Okay, so you see here now B is being cut into two times. We have B1 here and we have B2 here. What do we say about these lines? We say that this line B1, okay, this line that consists of an angle B1 and B2. So these angles, we say these two angles are what? Adjacent. These angles, angle B1 and B2, are adjacent angles in a straight line. And then the question says that what is special about angles that are adjacent? So we say that adjacent angles are said to be what? Supplementary. And one might wonder, what does the term supplementary mean? By being supplementary, they mean that when you add their angles, of which is B1 plus B2, they have to give you 180 degrees. So whenever you have a straight line that is joined by a certain line, and that line produces angles that are more than one, when you add those angles, they have to give you what? 180 degrees. Again, if you are told, this can be reversed. So if you are told that angle B1 plus angle B2 is equal to 180 degrees, and when you look at this one, you can see that angle B1 and angle B2 are adjacent. You then conclude by saying a line ABC is what? Is a straight line. So you can be told that you have a straight line ABC that has the straight line joined from D that cuts the angle B into part B1 and B2. Then when you add these two angles, they become adjacent angles. When you add them, they have to give you what? 180 degrees. Then let us move to another property. Suppose that you have your straight line here, and then you have your line cutting this straight line like this. You see that the other one was not cutting the straight line throughout. Okay, so in this case, we have this point here, of which is point E, and then we have A here, we have B here, we have C here, and we have D here. So if you can look carefully here, this straight line cut this straight line into four angles. So we have E1 now, E2, E3, as well as E4. What do we know about this? If you can look carefully, some people who are Orlando Pirate fans, they can see that, okay, now Matambo started to be joining one another. So in this case, we say that angle E1 is equal to angle E2, not E2, E3, by the way. So we say that these two angles are equal, of which is this one and this one. And whenever we write something in Euclidean geometry, we always have to be accompanied with a certain reasoning. So if you can look carefully, these two lines intersect one another. So a line AB intersect what? Line what? CD. Hence, we have E1 being equal to E3, and we have E4 being equal to E2. And then when we write Euclidean geometry, we always need to reason behind that. So whenever two lines intersect, we say that their vertical opposite angle, or their vertical opposite angles, are equal. Yeah, we say vertical opposite angles are what? Are equal. So in this case, we say E1 is equal to E2 because these two angles are vertically opposite. So the very same thing also with E2, we said E2 in this case is equal to what? Is equal to E4. The reason is same. Again, we say it is vertical opposite angles. So whenever we have two lines that joins one another or that intersect each other, we say that their vertical opposite angles are equal. Okay, then move to the last but not least property. This one, if you can see carefully, this one will be same exactly as the one that I drew above. So this one now, we have a scenario like this one. Look now, here we have, and then here is another one. Now in this case, I want you to look. So you see that this line is not extending any line. So now we have four. The straight line has now been cut it into four. I have AB. In this case, now I have my E here, and I have my D here, and I have my C here. So you see that this point, I have E1, I have E2, I have E3, and I have E4. So if you can look carefully here, the line did not intersect the straight line, but these straight lines, of which is the one of which is CE, DE, BE, as well as AE, they meet at the point E. So what do we say about this straight line? We have one point that is common. So in fact, we have angles around a point. What do we say about angles around the point? Okay, which angles am I referring to? I'm referring to E1 plus E2 plus E3 plus E4. We say when you add all of these angles, they should give you what? 360 degrees. And you use this as the result to say these are angles around the point. So you see, this is how we handle such problems. One, I said when we have lines, okay, it's a straight line ABC, and then there's a line that wanted to join this line ABC, of which is the line that came from D and then touches the line at B, such that the B is now split into two. It has an angle B1 and an angle B2. So we said angle B1 is adjacent to angle B2. As the result, we said adjacent angles are supplementary, and I even elaborated what do I mean by supplementary. Being supplementary means that when you add those angles, they are adding up to 180 degrees. Hence, you can be told that angle B1 plus angle B2 is equal to 180 degrees. And then when you will be required to conclude that the line that they are referring to is a straight line, but if they pointed adjacent angles that are add up to 180. If they said those adjacent angles are supplementary, you then know that whenever we deal with adjacent angles that are supplementary, it's whereby we are looking at what? At a straight line. So I hope I did manage to give you an idea on the properties of lines.